Kia ora guys, we're having a look at page 7 of the Numeric Reasoning Workbook. We're going to have a look at factors and how to find the highest common factors. So, factors. Factors are numbers that build up another number through multiplication. For example, 2 times 4 equals 8. So 2 and 4 would be factors of 8. Now, to be good at finding factors fast, you need to know what primes are, really. So prime numbers are numbers that you can't multiply two numbers other than one in itself to get it. For example, 7 is a prime number because you can only do 1 times 7 to get 7. There's no other combination that you can use to make it up. So examples of primes would be the number 2 because it's only 1 times 2, or 1 times 3 for 3. 4 is 4 a prime number? No, because 2 times 2 is 4, so we'll skip that. 5 is a prime. We just saw that 7 is a prime. Other examples would be 11, 13, 17, and 19. There's quite a few in that, in the first 20 numbers. I think that's everything. So what we'll do is we will have a look at how to find factors of a number. So let's say the number 28. Now, how do we get 28? It's an even number, so I know that 2 times something is going to be 28, and that something is 14, because 4 times 2 is 8, and 1 times 2 is 2. Now, because 2 is a prime number, we're going to put a little box around it, because there's nothing we can do to break that down anymore. But 14 we can break down a bit more. It's an even number, so 2 times something is 14, and that is 2 times 7. 2 is a prime, so we'll put a box around that. Ooh, look at that. 7 is actually a prime as well, so we'll put a box around that. So now we can start listing our factors. Now, factors always start from 1. 1 is always a factor. And then we have 2 as a factor because it's in our prime factor tree. Now, look at this. 2 times 2, you can get numbers that are in squares and you can multiply them around to see if there's some other factors hidden away in there. So we can try all of the different combinations. So 2 times 2 is 4, so that's a factor as well. We could do 2 times 7, but it's already been done here. So 7 we know is a factor. That's the next one. And other than that, we've tried all of the multiplying that we can, so we'll just list off the rest of the numbers that are in the factor tree. So 14 is there, and 28 is the final factor. So all of the factors of 28 are 1, 2, 4, 7, 14, and 28. Alright, let's choose another number, and we'll try it again. So let's say 30. So 30 is an even number, so it's going to be 2 times something is 30, and that is 2 times 15. Is 15 a prime? No, because 5 times something is going to get us 15. 5 times 3 gets us 15. And look at that, 3 and 5 are both primes. So that's as much as we can do on our tree. So let's list our factors. 1 is always a factor. 2's there in the list. 3's there in the list. What about 4? Let's try. No, they're not going to get us a 4. 5 is next. 2 times 3 is 6. So that's in there. 2 times 5 is 10. So that's in there. And that's all of the combinations I can think to do. So then we'll just list the rest of the things in our tree. 15 and 30. Nice. So all of the factors of 30 are 1, 2, 3, 5, 6, 10, 15, and 30. So now let's have a look at finding the highest common factor. What factor do these two have in common, and what's the highest one out of those? So is there a 30 in this list? No. Is there a 15 in this list? No. A 10? No. A 6? No. A 5? No. A 3? No. A 2? Yes. So the highest common factor is 2, because 2's in both of those lists. So the highest common factor of 28 and 30 is 2. Alright, sometimes that's called an HCF because we need to use that quite a bit when we're doing algebra for things like factorizing, quadratics and whatnot. Actually, I don't think we do use that in factorizing quadratics. When we're doing factorizing. So highest common factor of these numbers, 28 and 30, the HCF is 2.